Ratio and proportion, theory lecture SSC level. The concept of ratio and proportion forms a foundational part of quantitative aptitude. Understanding these is crucial for solving a wide range of problems in competitive exams like SSC. Let us first understand what a ratio is. A ratio is a comparison of two quantities of the same kind and in the same unit. It tells us how many times one quantity is contained in another. The ratio of two numbers and B is written as A, B is read as A is to B. For example, if a person has 100 rupees and another person has 400 rupees, the ratio of their amounts is 1, 4, which means the second person has 4 times the money of the first person. The most important point in ratios is that both quantities must be of the same type and unit. We cannot compare 5 kilograms with 5 rupees or 3 meters with 3 seconds. Ratios can be simplified just like fractions. For instance, 20, 60 can be simplified by dividing both numbers by their highest common factor, which is 20. Hence, 20, 60 becomes 1, 3. Ratios are often used to compare two or more parts of a whole. For example, if in a class there are 10 boys and 20 girls, the ratio of boys to girls is 10-20, which simplifies to 1, 2. This means that for every 1 boy, there are 2 girls. Ratios can also be expressed as fractions. So, 2, 3 can also be written as 2/3. Now, let us understand the concept of proportion. Proportion is an equation that states that two ratios are equal. If A, B equals C, D, then A, B, C, and D are said to be in proportion. This is also written as A, B, C, D, and is read as A is to B as C is to D. In proportion, the product of the means B and C is equal to the product of the extremes A and D. That is, a times D equals B times circa. This property helps in solving many problems based on proportion. Types of variation are closely linked to proportion. The term variation refers to how one quantity changes in relation to another. There are 3 main types of variation: direct variation, inverse variation, and joint variation. In direct variation, two quantities increase or decrease together. That means, if one quantity increases, the other also increases in the same ratio. Mathematically, this is written as x proportional y, or x, y equals constant. For example, if you buy more apples, you pay more money. So, the number of apples and the total cost vary directly. In inverse variation, when one quantity increases, the other decreases in such a way that the product remains constant. That is, x proportional 1, y, or x times y equals constant. A common example is speed and time. If you increase the speed of a vehicle, the time taken to cover the same distance decreases. If you reduce the speed, the time increases. Their product speed times time remains constant for a fixed distance. Joint variation occurs when a quantity varies directly as one quantity and inversely as another at the same time. For example, the amount of work done can vary directly with the number of workers and inversely with the number of days taken. That means if you increase the number of workers, the time taken reduces, and if the number of workers decreases, the time taken increases. These concepts are the building blocks for solving complex arithmetic and word problems. The key is to identify whether the problem is based on a ratio, a proportion, or a form of variation. Once that is clear, you can apply the correct mathematical principle to solve it quickly and accurately. Practice questions SSC previous year style. Question 1. If the ratio of the ages of two people is 4, 5 and the sum of their ages is 72 years, what is the age of the elder person? Solution. Let the ages be 4x and 5x. Then, 4x plus 5x equals 72, right pointing arrow 9x equals 72, right pointing arrow x equals the elder person's age equals 5x equals 5 times 8 equals 40 years. Question 2. A car travels at a speed which is inversely proportional to the time taken. If it covers a distance in 4 hours at 60 kilometers per hour, how much time will it take if the speed is increased to 80 kilometers per hour? Solution. Speed times time equals constant, right pointing arrow 60 times 4 equals 80 times t 240 equals 80 t, right pointing arrow t equals 3 hours. Answer, 3 hours. Question 3. If 6 men can complete a work in 8 days, how many men are required to complete the same work in 4 days? Solution. Men proportional 1 days inverse variation, right pointing arrow 6 times 8 equals x times 4, right pointing arrow x equals 12. Answer, 12 men. Let me know the next topic you want. I'll continue with the same detailed paragraph style lecture format. You said. Continue proportions increase, decrease in ratios applications in real life problems. ChatGPT said. Here's the detailed SSC level theory lecture in pure paragraph format, continuing from the previous part and covering. Continued proportions. Increase, decrease in ratios. Applications in real life problems. Continued proportions. Continued proportion is a special case of proportion where 3 quantities are said to be in continued proportion if the first is to the second as the second is to the third. In mathematical terms, if A, B equals B, C, then A, B, and C are said to be in continued proportion. The middle term B is called the mean proportional, and the third term C is the third proportional to A and B. From the definition, we can derive that B squared equals a times C, since in a proportion, the product of the means equals the product of the extremes. So if A, B equals B, C, then a times C equals B times B or B squared. This formula helps in quickly finding the missing term when two terms are known. For example, if A equals 2 and B equals 4, then C can be found by using the formula B squared equals a times C, right pointing arrow 16 equals 2 times C, right pointing arrow C equals 8. Thus, 2, 4 equals 4, 8, and 2, 4, 8 are in continued proportion. Continued proportion is often used in geometry and algebra problems, especially those involving similar triangles or scaling of quantities where a single ratio is extended over 3 terms. Increase and decrease in ratios. When one or both quantities in a ratio are increased or decreased, the ratio changes. Understanding how a change in the value of a term affects the overall ratio is important in many real-world problems. Let's explore how this works. If the original ratio is A, B, and A is increased by a certain percentage, then the new value becomes A plus a times percent increase 100. The same applies to a decrease. If both values change, then both are adjusted accordingly and a new ratio is formed. For example, if the ratio of two numbers is 3, 4, and the first number is increased by 50%, the new number becomes 3 plus 1.5 equals 4.5. So, the new ratio becomes 4.5, 4 and 9, 8 after simplifying. Similarly, if the second number is decreased by 25%, it becomes 4 to 1 equals 3, and the new ratio becomes 3, 3 equals 1, 1. This concept is important for solving percentage-based word problems, where we are asked to find the new ratio after an increase or decrease. The key step is to first apply the increase or decrease to the relevant term and then express both updated terms in a simplified ratio. Another important application is when we are required to find what percentage change in one quantity would equal a desired change in the ratio. In such problems, we must often work backward using proportion and percentage concepts. Applications in real-life problems. The concepts of ratio and proportion are extremely useful in day-to-day life and in competitive exams. They are used in problems related to mixing, dividing amounts, comparing speeds, calculating costs, profit sharing, scaling of recipes, and interpreting maps. One common application is in partnership problems. Suppose 2 or more people invest money in a business for different durations. The profit or loss is shared in the ratio of their effective investments, calculated as the product of amount invested in time. For instance, if A invests rupee 3,000 for 4 months and B invests 6,000 rupees for 2 months, the profit will be divided in the ratio of 3,000 times 4, 6,000 times 2 equals 12,000, 12,000 equals 1, 1. Another practical use is in mixing problems, such as mixing milk and water or different grades of oils. If two substances are mixed in a certain ratio, and we are told the final quantity or cost, we can use ratio and proportion principles to find individual quantities or costs. For example, if 4 liters of milk is mixed with 6 liters of water, the ratio of milk to water is 4, 6 equals 2, 3. In problems of work and time, if two people work together, their efficiency is often compared in the form of a ratio. If a can do a piece of work in 5 days and B in 10 days, their work ratio is 1/5, 1/10 equals 2, 1. So it is twice as much work as B in the same time. Speed, distance, and time problems also rely on the concept of ratio. For example, if two cars travel the same distance but at different speeds, the time taken by each is inversely proportional to their speeds. So if car A and car B travel at 60 kilometers per hour and 40 kilometers per hour respectively, the time taken by A and B are in the ratio 2, 3. Another very useful area is recipe adjustments, where ingredients are scaled up or down maintaining the ratio. If a recipe requires ingredients in the ratio 2, 3, 5 and we are preparing for 10 people instead of 5, we double each quantity while keeping the ratio unchanged. In map reading, the scale uses a ratio. For example, a scale of 1, 100,000 means 1 centimeter on the map represents 100,000 centimeters or 1 kilometer on the ground. Thus, mastering ratio and proportion equips you to solve a wide range of SSC questions and also strengthens your practical math skills for everyday use. Practice questions SSC previous year style. Question 1. Find the third proportional to 4 and 6. Solution. Let the third proportional be x. Then 4, 6 equals 6. X right pointing arrow 4 x equals 36 right pointing arrow x equals 9 answer 9. Question 2. The ratio of two numbers is 5, 6. If each number is increased by 4, the new ratio becomes 3, 4. What are the numbers? Solution. Let the numbers be 5x and 6x. Then 5x plus 4, 6x plus 4 equals 3 quarters right pointing arrow cross multiply. 4 5x plus 4 equals 3, 6x plus 4 right pointing arrow 20x plus 16 equals 18x plus 12 right pointing arrow 2x equals minus 4 right pointing arrow x equals minus 2. This leads to negative values, which is not possible. Let's try another way. Let the numbers be and be such that a, b equals 5, 6 right pointing arrow equals 5x, b equals 6x, 5x plus 4, 6x plus 4 equals 3 quarters right pointing arrow cross multiply. 4 5x plus 4 equals 3, 6x plus 4 right pointing arrow 20x plus 16 equals 18x plus 12 right pointing arrow 2x equals minus 4 right pointing arrow x equals 2. Still negative. This implies there's some error. Recheck the options in exam or revise the question if needed. Let's pick a new question. Question 3. A and b divide 600 rupees in the ratio 2, 3. How much money does b get? Solution. Total parts equals 2 plus 3 equals 5. B share equals 3/5 times 600 equals 360 rupees. Answer. 360 rupees. Let me know the next topic you'd like. I'll continue with the same high quality, no table, full paragraph explanation style. You said. Continued proportions increase, decrease in ratios applications in real life problems. ChatGPT said. Here's the continued, full-length SSC level theory lecture in pure paragraph format covering continued proportions with deeper explanation. Increase, decrease in ratios with concept building and examples. Applications in real life problems, practical and exam focused. Continued proportions, full theory. Continued proportion is a specific form of proportion where three quantities are in proportion in such a way that the first is to the second as the second is to the third. That is, if a, b equals b, c, then the numbers a, b, and c are said to be in continued proportion. The middle term, b, is called the mean proportional, and the third term, c, is the third proportional to a and b. This concept is mostly seen in questions related to numbers, geometry, and progression-based reasoning in SSC exams. The key identity used in continued proportion is that the square of the mean proportional equals the product of the extremes. In mathematical terms, b squared equals a times circa. If two numbers are given, say and b, then the third proportional c can be found using the formula c equals b squared a. Similarly, if a and c are known and you're asked to find the mean proportional b, then you can use b equals square root a times c. Let's take an example. Suppose 2, 4, and x are in continued proportion. Then 2, 4 equals 4, x right pointing arrow 4 squared equals 2 times x right pointing arrow 16 equals 2 x right pointing arrow x equals 8. So the third number is 8. Similarly, if you are told that a number lies between 3 and 27 in continued proportion, it means 3, x equals x, 27. Then x squared equals 3 times 27 equals 81 right pointing arrow x equals 9. So 3, 9, 27 are in continued proportion. This concept is useful not only in number problems but also in geometry, particularly when dealing with similar triangles where the sides are in continued proportion. It is also seen in mensuration-based problems involving scale models or patterns. Increase and decrease in ratios, full concept. When the value of one or both terms of a ratio changes due to increase or decrease, the resulting ratio also changes. Understanding the relationship between original and modified values is essential to solve problems involving population growth, price hike, income expenditure balance, profit loss comparison, and so on. Suppose the original ratio is a, b. If a increases by x%, the new value of a becomes a plus a times x 100. Similarly, if b decreases by y%, then the new value of b becomes b times y 100. These new values form the new ratio, which can be simplified to its lowest terms for the final answer. For instance, suppose the original ratio of salaries of two employees a and b is 3, 4. If it gets a 50% hike and b's salary is reduced by 25%, then a's new salary is 3 plus 50% of 3 equals 3 plus 1.5 equals 4.5, and b's new salary is 4 25% of 4 equals 4 to 1 equals 3. So, the new ratio becomes 4.5, 3 equals 3, 2. Sometimes, you're asked by how much a ratio changes when only one term is increased or decreased. In such cases, always update the change value first and then simplify the resulting pair. You might also be asked the percentage change in the ratio itself, which can be found by comparing the difference between the new and old ratio values, especially if the ratios are in the form of fractions. This concept also applies to comparing two scenarios, such as, if the price of petrol increases by 25%, what is the percentage decrease in consumption required to maintain the same expenditure? This type of question is based on inverse variation, where the product of price and consumption remains constant. If price increases by 25%, new price is 1.25 times the original, so consumption must become 1 over 1.25 equals 0.8, which means a 20% decrease in consumption. Applications in real life problems, practical and exam oriented. Ratio and proportion are not just theoretical topics, they are tools we use in real life constantly. In SSC exams, this real life utility is transformed into practical, word-based problems that test your logic, clarity of concept, and calculation skills. One major application is in division of amounts. Suppose a total sum of money is to be divided among people in a given ratio. For example, 1,200 rupees is to be divided among a, b, and c in the ratio 2, 3, 5. First, add the parts. 2 plus 3 plus 5 equals 10. Then divide the total amount in these parts. A gets 2 tenths of 1,200 rupees equals 240 rupees. B gets 3 tenths of 1,200 rupees equals 360 rupees. And C gets 5 tenths equals 600 rupees. Another classic SSC application is in mixture problems, such as milk and water being mixed in certain ratios. For example, a container has a mixture of milk and water in the ratio 3, 2. If 20 liters of the mixture is taken out, how much milk and how much water was removed? Here, use the same ratio for division. 3/5 of 20 equals 12 liters of milk and 8 liters of water. Work and wages problems also use ratio. If two workers and B are paid wages in the ratio of their efficiency, and a completes work in 10 days and B in 20 days, then A's efficiency is 1/10 and B's is 1/20. Their efficiency ratio is 2, 1, so if total wages are 900 rupees, A gets 600 rupees and B gets 300 rupees. In speed and time problems, ratio is used in both direct and inverse forms. If distance is constant, speed and time are inversely proportional. For example, if one car travels at 60 kilometers per hour and another at 90 kilometers per hour, the time taken is in the ratio 3, 2. This principle helps solve many real-life situations involving travel time, fuel cost, and transportation planning. In cooking or scaling recipes, ratio is used to maintain consistency. If a recipe uses ingredients in the ratio 1, 2, 3 and you want to prepare triple the quantity, you multiply each ingredient by 3, maintaining the ratio throughout. Similarly, architects use scale ratios when drawing floor plans. For example, a 100 scale means 1 centimeter on the drawing represents 100 centimeters in real life. Profit sharing problems also rely heavily on ratio. For example, if two partners invest 4,000 rupees and 6,000 rupees in a business and the profit is 2,000 rupees, the profit is shared in the ratio 4, 6 equals 2, 3. So the first partner gets 800 rupees and the second gets 1,200 rupees. In currency exchange, unitary method often works with ratios. For instance, if 80 rupees equals $1.60, then we use ratios to find how many rupees equal $5 or how many dollars we get for 400 rupees. All these applications show how deeply embedded the concept of ratio and proportion is in everyday decisions, from business to household management, and how essential it is for excelling in SSC exams. Practice questions SSC level. Question 1. Find the mean proportional between 16 and 100. Solution. Mean proportional equals square root 16 times 100 equals square root 1600 equals 40. Question 2. A's salary is to B's salary is 3, 5. If it gets a 40% hike and B gets a 20% hike, what will be the new ratio? Solution. A's new salary equals 3 plus 40% of 3 equals 3 plus 1.2 equals 4.2. B's new salary equals 5 plus 20% of 5 equals 5 plus 1 equals 6. New ratio equals 4.2. 6 equals 710. Answer. 710. Question 3. 360 rupees is to be divided among A, B, and C in the ratio 5, 4, 1. How much does it receive? Solution. Total parts equals 5 plus 4 plus 1 equals 10. A's share equals 5 tenths times 360 equals 180 rupees. Let me know the next topic and I'll continue with this same in-depth, paragraph-based, no table explanation style. You said, percentage. Conversion of fractions to percentage and vice versa, percentage increase and decrease. ChatGPT said. Here is your complete SSC level theory lecture on percentage, covering basic concept of percentage, conversion of fractions to percentage and vice versa, percentage increase and decrease. As requested, the explanation is given in pure paragraph format with maximum detail and no use of tables or codes. Percentage, concept and explanation. The word percentage means per hundred and is denoted by the symbol percent. It is a way of expressing a number as a fraction of 100. So, 25% simply means 25 out of 100 or 25 100ths in fractional form. In practical terms, percentage is used to compare quantities, express changes, or indicate ratios in a standard format that is easy to interpret and compare. Percentages are used widely in everyday life, in discounts, profit and loss, exams, elections, growth rates, and much more. To understand how percentages work, suppose you score 60 marks out of 100 in a test. This means your score is 60%, since 60 out of 100 is 60%. But if the total marks were 200 and you scored 60, then your percentage would be 60 200ths times 100 equals 30%. Therefore, percentage equals obtained value total value times 100. Percentages can also be greater than 100, especially when something increases beyond its original value. For example, if your income was 10,000 rupees and now it is 12,500 rupees, then your new income is 125% of your old income, which means a 25% increase. Conversion of fractions to percentage and vice versa. Converting fractions to percentages is an essential skill. To convert any fraction into a percentage, multiply the fraction by 100 and add the percent sign. For example, to convert 3/4 into a percentage, do 3/4 times 100 equals 75%. So, 3/4 is equal to 75%. Similarly, 1/2 is 1/2 times 100 equals 50%, and 2/5 is 2/5 times 100 equals 40%. This method applies to both proper and improper fractions. Suppose we have 7/5. Then, 7/5 times 100 equals 140%. That means 7/5 is 140%, which is more than the whole. For decimals, first convert them into fractions and then into percentages. For example, 0.2 equals 1/5, and 1/5 equals 20%. Now let us understand how to convert a percentage into a fraction. To do this, simply divide the percentage by 100 and simplify. For example, to convert 25% into a fraction, write 25 100ths equals 1/4. Similarly, 80% becomes 80 100ths equals 4/5. Even percentages above 100 can be written as fractions. For example, 150% equals 150 100ths equals 3/2. Learning these standard conversions like 1/2 equals 50%, 1/3 equals 33.33%, 2/3 equals 66.66%, 1/4 equals 25%, etc. helps in quickly solving many SSC problems, especially when options are in percentage form or when estimating approximate values. Percentage increase and decrease. This is one of the most commonly tested concepts in SSC exams. It is used in price change, salary changes, population growth, and discount related problems. When a quantity increases by a certain percentage, the new value is calculated as new value equals original value plus percentage of increase times original value, or mathematically, new value equals original times 1 plus r 100, where r is the percentage increase. Similarly, for decrease, new value equals original value minus percentage of decrease times original value, or new value equals original times 1 minus r 100. For example, if the price of an item is 200 rupees and it increases by 10%, the increased price is 200 rupees plus 10% of 200 rupees equals 200 rupees plus 20 rupees equals 220 rupees. Alternatively, use the formula 200 rupees times 1 plus 10 100ths equals 200 rupees times 1.1 equals 220 rupees. If something decreases, for instance, a shirt price at 800 rupees is marked down by 25%, the new price is 800 rupees minus 25% of 800 rupees equals 800 rupees minus 200 rupees equals 600 rupees. Using the formula, 800 rupees times 1 minus 25 100ths equals 800 rupees times 0.75 equals 600 rupees. It is important to note that percentage increase or decrease is always calculated on the original value, unless otherwise stated. Sometimes, questions involve successive changes. For example, if a price is increased by 10% and then again by 20%, the net percentage increase is not 30%, but more. The formula for successive percentage changes, net change equals a plus b plus ab 100, where and b are the two successive percentage changes. So, in the above example, net change equals 10 plus 20 plus 10 times 20, 100 equals 30 plus 2 equals 32%. Hence, the price increases overall by 32%. This formula also applies when one change is an increase and the other is a decrease. Suppose the price increases by 20% and then decreases by 10%, then the net changes 20 minus 10 minus 20 times 10, 100 equals 10 minus 2 equals 8% increase. Another important concept is percentage change between two values. If the value changes from a to b, then percentage change equals b minus a times 100. If b and gt, a, it's a percentage increase. If b and lt, a, it's a percentage decrease. For example, if a salary increases from 6,000 rupees to 7,500 rupees, the increase is 1,500 rupees. So, the percentage increase is 1,500 6,000 times 100 equals 25%. If the population decreases from 20,000 to 1,080,000, the decrease is 12,000. So, percentage decrease equals 12,100 20,000 times 100 equals 10%. Practice questions SSC level. Question 1. Convert 7/8 to percentage. Solution. 7/8 times 100 equals 87.5%. Answer. 87.5%. Question 2. If the price of a product increases from 240 rupees to 300 rupees, what is the percentage increase? Solution. Increase equals 60 rupees. Right pointing arrow percentage equals 60 240 times 100 equals 25%. Answer. 25%. Question 3. A quantity is increased by 20% and then decreased by 10%. What is the net percentage change? Solution. Net change equals 20 minus 10 minus 20 times 10. 100 equals 10 minus 2 equals 8% increase. Answer. 8% increase. Let me know your next topic, and I will continue with the same detailed paragraph style explanation tailored for SSC preparation. You said. Successive percentage changes comparison of quantities using percentages. ChatGPT said. Here's the detailed SSC level theory lecture in pure paragraph format covering successive percentage changes. Comparison of quantities using percentages. This explanation is complete, exam focused, and does not use any tables or codes as per your instructions. Successive percentage changes. In many real life and exam scenarios, a quantity undergoes two or more percentage changes one after another. This is called successive percentage change. These changes are not simply added or subtracted because each change applies to the updated value, not the original. The correct method is to use a specific formula that accounts for the compound effect of both changes. When two percentage changes are applied one after the other, say, increase by a percent followed by increase by b percent, the total or net percentage change is given by the formula. Net change equals a plus b plus ab 100. This formula gives the exact overall change in percentage and is valid for all combinations of increase and decrease. Let's take an example. Suppose a shirt's price is increased by 20% and then again by 10%. The net increase is not just 30%, but calculated as 20 plus 10 plus 20 times 10 100 equals 30 plus 2 equals 32%. So, the final price is 32% higher than the original price. If one change is an increase and the other is a decrease, then the formula becomes net change equals a minus b minus ab 100. Let's take an example. A fan's price is increased by 25% and then decreased by 20%. The net change is 25 minus 20 minus 25 times 20 100 equals 5 minus 5 equals 0%. That means, after both changes, the final price remains the same as the original. If both changes are decreases, the formula becomes net decrease equals minus a plus b minus ab 100. This still gives the correct value but with a negative sign, indicating decrease. This concept is also used when prices or salaries change in steps, or when population increases or decreases in successive years. For example, if a population increases by 10% each year, then after 2 years, the increase is not just 20%, but 10 plus 10 plus 10 times 10 100 equals 21%. The formula also extends to more than 2 successive changes. In that case, apply the 2-change formula step by step. First find the result of the first 2 changes, then combine it with the third change using the same formula. Successive percentage change is a high-scoring area in SSC exams and is often used in combination with real-life themes such as price changes, discounts followed by taxes, salary hikes followed by reductions, etc. Comparison of quantities using percentages. Percentages are also used to compare 2 or more quantities. This comparison tells us how much more or less one value is than another, expressed in percentage terms. This is especially useful when 2 values are not in easily comparable formats or when a direct numerical comparison isn't meaningful. There are 2 key types of comparisons. How much more or less is one quantity than another in percentage terms? What percentage of one quantity is another? Let us consider the first case. Suppose one person earns 8,000 rupees and another earns 10,000 rupees. We want to know how much less the first person earns compared to the second in percentage terms. The difference is 2,000 rupees, and we compare this to the second person's income. 2,000 10,000 times 100 equals 20%. So, the first person earns 20% less than the second. If the reverse is asked, how much more the second person earns than the first, the percentage is still calculated on the first person's salary. 2,000 8,000 times 100 equals 25%. So, the second person earns 25% more than the first. Therefore, percentage comparison depends on which quantity you are comparing against. Always compare the difference to the quantity you are told to base the percentage on. Now take the second case. To find what percentage one quantity is of another, use the formula. First quantity, second quantity times 100. If a student scores 45 out of 60, then the percentage score is 45 60ths times 100 equals 75%. So, 45 is 75% of 60. These comparisons help in questions like, A is 25% more than B, then B is how much less than A. In such cases, always express values relatively. If B equals 100, then A equals 125. Now, the difference is 25, and percentage difference from A's perspective is 25 125ths times 100 equals 20%. So, B is 20% less than A. This is a commonly tested trap in SSC exams. Students often wrongly assume that 25% more and 25% less are symmetrical, but they are not. A being 25% more than B doesn't mean B is 25% less than A. It is 20% less. Similarly, if A is 20% less than B, then A equals 80 and B equals 100. Now, B is 20 80ths times 100. Similarly, if A is 20% less than B, then A equals 80 and B equals 100. Now, B is 20 80ths times 100 equals 25% more than A. This concept of percentage-based comparison is also applied in profit loss, marks scored, salary increase, and price changes. It is also common in comparing heights, weights, or quantities of materials. To avoid mistakes, always fix one value as a base, usually 100, and calculate accordingly. Practice questions SSC level. Question 1. A value is increased by 10% and then by 20%. What is the net percentage increase? Solution. 10 plus 20 plus 10 times 20 100ths equals 30 plus 2 equals 32%. Question 2. A number is first increased by 25% and then decreased by 20%. What is the overall change? Solution. 25 minus 20 minus 25 times 20 100ths equals 5 minus 5 equals 0%. Question 3. A earns 4,000 rupees and B earns 5,000 rupees. How much less does A earn compared to B in percentage? Solution. 1,000 5,000 times 100 equals 20%. Question 4. B earns rupee 1,000 more than A if A earns 4,000 rupees. How much more does B earn in percentage? Solution. 1,000 4,000 times 100 equals 25%. Let me know the next topic and I will continue with the same paragraph-based, detailed, exam-oriented explanation style. You said. Problems on population, income, expenditure. ChatGPT said. Here is your SSC level theory lecture in pure paragraph format covering problems on population, problems on income and expenditure. This explanation is given in maximum detail, without any tables or codes, and is fully exam-oriented for SSC preparation. Problems on population. Population-based problems in SSC exams often involve changes in population due to percentage increase or decrease over a specific period, usually a year. These problems test your understanding of successive percentage change, compound growth, and reverse calculation. The most important formula used in population problems is population after n years equals p times 1 plus r 100 to the power of n. Where p is the initial population, r is the annual rate of increase in percentage, and n is the number of years. If the population is decreasing, we replace 1 plus r 100 with 1 minus r 100. This is based on the principle of compound growth or decay, where each year's change is applied not to the original population, but to the updated population after previous years. Let us take an example. If a town's population is 100,000 and it increases by 2% annually, what will be the population after 2 years? Using the formula, 100,000 times 1 plus 2 100ths squared equals 100,000 times 1.02 times 1.02 equals 104,040. So, after 2 years, the population will be 104,040. Sometimes, you are asked to find the original population, given the population after growth. In such cases, use reverse calculation. Suppose the population after 1 year is 102,000 and it increased by 2%. Then, the original population was 102,000 divided by 1.02 equals 100,000. A variation of these problems is when the growth is not annual but over months or decades. In such cases, adjust the time n accordingly. For example, if the rate is per decade and the time is 3 decades, then use n equals 3. If the rate is per month and time is in months, proceed the same way. In some SSC questions, the population may increase at one rate for a few years and then at another rate for the following years. In that case, apply the growth step by step for each time period. Problems on income and expenditure. Problems based on income and expenditure revolve around the relationship between a person's income, expenditure, and savings. These are interlinked by the basic formula. Income equals expenditure plus savings. This means whatever you earn is either spent or saved. Based on this, most problems require calculating one of the 3 quantities if the other 2 are known. For example, if a person earns 25,000 rupees per month and spends 18,000 rupees, then the savings are 25,000 rupees minus 18,000 rupees equals 7,000 rupees. Conversely, if the income is 30,000 rupees and savings are 6,000 rupees, then the expenditure must be 24,000 rupees. A frequent variation involves percentage-based expenditure or savings. If a person saves 20% of their income, it means expenditure is 80% of the income. Suppose income is 50,000 rupees and savings are 20%, then savings equals 20% of 50,000 rupees equals 10,000 rupees. The expenditure is the rest, i.e., 40,000 rupees. Sometimes the question gives the expenditure and savings and asks for income. For instance, if savings are 12,000 rupees and they form 25% of income, then income equals 100% and savings equals 25%. So, 12,000 rupees corresponds to 25%, and the total income equals 12,000 times 100 divided by 25 equals 48,000 rupees. Another commonly tested concept is percentage increase or decrease in income and/or expenditure and its effect on savings. If income increases by a certain percentage and expenditure also changes, the question may ask about the net effect on savings. Let us take an example. A person's income increases by 10%, but his expenditure increases by 5%. What is the percentage increase in savings? Let us assume original income equals 100 rupees and original expenditure equals 80 rupees, then original savings equals 20 rupees. Now, income increases by 10%, right pointing arrow, new income equals 110 rupees, expenditure increases by 5%, right pointing arrow, new expenditure equals 84 rupees, so new savings equals 110 rupees minus 84 rupees equals 26 rupees. Increase in savings equals 6 rupees, right pointing arrow, percentage increase equals 6 20ths times 100 equals 30%, so savings increased by 30%. This kind of problem tests logical application of percentage changes and demands clear understanding of how income and expenditure impact savings. In some questions, you may also be given a ratio of income to expenditure. Suppose income and expenditure are in a ratio of 5, 4. This means for every 5 rupees earned, 4 rupees is spent, and 1 rupee is saved. If actual savings are 5,000 rupees, then the unit ratio for savings is 1 part, which corresponds to 5,000 rupees. So, total income is 5 parts equals 25,000 rupees. Such ratio-based income expenditure problems are also frequently tested in SSC exams under arithmetic word problems. In advanced questions, savings may vary over time, or the question may be framed around, a person increases his savings by reducing expenditure, and you will be asked to find the effect on income or vice versa. To solve these, always go back to the basic formula and use either assumed values or unitary method. Practice questions SSC level. Question 1. The population of a village is 20,000. It increases by 5% every year. What will be the population after 2 years? Solution. Population equals 20,000 times 1 plus 5 100 squared equals 20,000 times 1.1025 equals 22,050. Question 2. A person spends 85% of his income. If his savings are 3,000 rupees, what is his income? Solution. If 85% is spent, then 15% is saved. So, 15% of income equals 3,000 rupees. Right pointing arrow income equals 3,000 times 100 divided by 15 equals 20,000 rupees. Question 3. Question 3. A person's income increased by 15% and his expenditure increased by 10%. If his initial income was 40,000 rupees and expenditure 30,000 rupees, what is the percentage increase in savings? Solution. Initial savings equals 40,000 minus 30,000 equals 10,000 rupees. New income equals 46,000. New expenditure equals 33,000. Right pointing arrow. New savings equals 13,000. Increase in savings equals 3,000 rupees. Right pointing arrow. Percent increase equals 3,000. 10,000 times 100 equals 30%. Let me know your next topic, and I'll continue with the same in-depth, paragraph style, exam focused explanation. You said. Profit, loss and discount, cost price, selling price, marked price, profit, loss percent, discount percent. ChatGPT said. Here is your SSC level theory lecture on the topic profit, loss, and discount, covering cost price, selling price, and marked price. Profit, loss percentage. Discount percentage. This explanation is written in pure paragraph format, in maximum detail, with no tables or codes, and tailored for SSC exam preparation. Cost price, selling price, and marked price. In any commercial transaction, there are 3 important values involved: cost price CP, selling price SP, and marked price MP. Cost price is the amount paid by the shopkeeper or seller to purchase the goods. It is the investment amount and serves as the baseline for calculating profit or loss. For example, if a shopkeeper buys a shirt for 300 rupees, then the cost price is 300 rupees. Selling price is the amount for which the seller actually sells the goods to the customer. If the seller sells the shirt for 350 rupees, then the selling price is 350 rupees. The difference between the cost price and selling price determines whether there is a profit or loss. Marked price, also called list price or label price, is the price printed on the product before any discount is applied. Sellers usually mark the price higher than the cost to allow for discounts or bargaining. For example, if a shirt's marked price is 500 rupees but the seller gives it price, marked price, profit, loss percent, discount percent. ChatGPT said. Here is your SSC level theory lecture on the topic profit, loss, and discount, covering cost price, selling price, and marked price. Profit, loss percentage. Discount percentage. This explanation is written in pure paragraph format, in maximum detail, with no tables or codes, and tailored for SSC exam preparation. Cost price, selling price, and marked price. In any commercial transaction, there are 3 important values involved: cost price CP, selling price SP, and marked price MP. Cost price is the amount paid by the shopkeeper or seller to purchase the goods. It is the investment amount and serves as the baseline for calculating profit or loss. For example, if a shopkeeper buys a shirt for 300 rupees, then the cost price is 300 rupees. Selling price is the amount for which the seller actually sells the goods to the customer. If the seller sells the shirt for 350 rupees, then the selling price is 350 rupees. The difference between the cost price and selling price determines whether there is a profit or loss. Marked price, also called list price or label price, is the price printed on the product before any discount is applied. Sellers usually mark the price higher than the cost to allow for discounts or bargaining. For example, if a shirt's marked price is 500 rupees but the seller gives a 20% discount, the selling price becomes 400 rupees, but the marked price is still 500 rupees. The relationship among the 3 is as follows. If no discount is given, marked price equals selling price. If discount is given, selling price equals marked price minus discount. Sometimes, a shopkeeper may increase the marked price above the cost price and then offer a discount. This can still result in a profit if the selling price remains above the cost price. This is a common exam situation and also reflects real-life business tactics. Profit and loss, concept and percentage. Profit occurs when the selling price is higher than the cost price. That is, profit equals selling price minus cost price. Loss occurs when the selling price is lower than the cost price. That is, loss equals cost price minus selling price. The profit percentage is calculated on the cost price, using the formula, profit percent equals profit, cost price times 100. Similarly, the loss percentage is also calculated on the cost price, loss percent equals loss, cost price times 100. Let us take examples. If a trader buys a chair for 800 rupees and sells it for... This explanation is written in pure paragraph format, in maximum detail, with no tables or codes, and tailored for SSC exam preparation. Cost price, selling price, and marked price. In any commercial transaction, there are 3 important values involved: cost price CP, selling price SP, and marked price MP. Cost price is the amount paid by the shopkeeper or seller to purchase the goods. It is the investment amount and serves as the baseline for calculating profit or loss. For example, if a shopkeeper buys a shirt for 300 rupees, then the cost price is 300 rupees. Selling price is the amount for which the seller actually sells the goods to the customer. If the seller sells the shirt for 350 rupees, then the selling price is 350 rupees. The difference between the cost price and selling price determines whether there is a profit or loss. Marked price, also called list price or label price, is the price printed on the product before any discount is applied. Sellers usually mark the price higher than the cost to allow for discounts or bargaining. For example, if a shirt's marked price is 500 rupees but the seller gives a 20% discount, the selling price becomes 400 rupees, but the marked price is still 500 rupees. The relationship among the 3 is as follows. If no discount is given, marked price equals selling price. If discount is given, selling price equals marked price minus discount. Sometimes, a shopkeeper may increase the marked price above the cost price and then offer a discount. This can still result in a profit if the selling price remains above the cost price. This is a common exam situation and also reflects real-life business tactics. Profit and loss, concept and percentage. Profit occurs when the selling price is higher than the cost price. That is, profit equals selling price minus cost price. Loss occurs when the selling price is lower than the cost price. That is, loss equals cost price minus selling price. The profit percentage is calculated on the cost price, using the formula, profit percent equals profit, cost price times 100. Similarly, the loss percentage is also calculated on the cost price, loss percent equals loss, cost price times 100. Let us take examples. If a trader buys a chair for 800 rupees and sells it for 1,000 rupees, then profit equals 1,000 minus 800 equals 200 rupees. Profit percent equals 200 800 times 100 equals 25%. If the same share is sold for 700 rupees, then there is a loss. Loss equals 800 minus 700 equals 100 rupees. Loss percent equals 100 800 times 100 equals 12.5%. It is important to remember that profit or loss is always calculated on the cost price, unless specified otherwise. A common mistake in exams is to use selling price as the base, which leads to incorrect answers. Sometimes, questions give profit or loss percentage and ask for either cost price or selling price. In such cases, use reverse application. For example, if a shopkeeper gains 20% and the selling price is 120 rupees, then cost price equals 120. 1 plus 20 100 equals 120 over 1.2 equals 100 rupees. Similarly, if the loss is 25% and selling price is 75 rupees, then cost price equals 75. 1 minus 25 100 equals 75 over 0.75 equals 100 rupees. Also, you may encounter problems where a person sells two items at the same selling price, gaining on one and losing on the other. In such problems, if the gain percent and loss percent are equal, there is always a net loss, and it is equal to common percent loss or gain squared 100. For example, if the trader gains 10% on one item and loses 10% on another, then overall loss equals 10 squared 100 equals 1%. Discount, concept and percentage. Discount is a reduction in the marked price of an article, usually offered to attract buyers. It is always calculated on the marked price, not on the cost or selling price. The formula for discount is discount equals marked price minus selling price. The discount percentage is given by discount percent equals discount marked price times 100. Let's say a book is marked at 500 rupees and sold for 450 rupees. Then, discount equals 500 minus 450 equals 50 rupees. Discount percent equals 5500 times 100 equals 10%. In most SSC problems, discount is applied to the marked price to arrive at the selling price. Sometimes, successive discounts are applied. For example, a shopkeeper offers two successive discounts of 10% and 20%. These cannot be added directly, not 30%. Instead, use the formula. Net discount percent equals A plus B minus AB 100, where and B are the two discount percentages. In our example, 10 plus 20 minus 10 times 20 100. Net discount percent equals A plus B minus AB 100, where and B are the two discount percentages. In our example, 10 plus 20 minus 10 times 20 100 equals 30 minus 2 equals 28%. So, the net discount is 28%. Successive discount problems are frequently tested and often involve calculating final selling price or effective discount. Another type of question asks how much discount must be given to sell an article at a certain profit. In such cases, calculate the required selling price based on the cost price and desired profit, then calculate the discount needed to reach the selling price from the marked price. Sometimes, the question is framed as, a shopkeeper marks up goods by 25% and gives a 10% discount. What is his profit percent? Here, use the logic. Marked price equals 125% of cost price. Selling price equals 90% of marked price equals 90% of 125 equals 112.5%. So, profit equals 112.5 minus 100 equals 12.5%. In such questions, assume cost price is 100 rupees, calculate marked price, apply discount, and compare with the cost price to find profit or loss. Practice questions SSC level. Question 1. A trader buys an article for 800 rupees and sells it for 920 rupees. Find the profit percentage. Solution. Profit equals 920 minus 800 equals 120 rupees. Profit percent equals 120 hundredths times 100 equals 15%. Question 2. The marked price of the watch is 1,500 rupees. A discount of 20% is given. What is the selling price? Solution. Discount equals 20% of 1,500 equals 300 rupees. Selling price equals 1,500 minus 300 equals 1,200 rupees. Question 3. A shopkeeper marks goods 40% above cost price and allows a 10% discount. What is his gain? Practice questions SSC level. Practice questions SSC level. Question 1. A trader buys an article for 800 rupees and sells it for 920 rupees. Find the profit percentage. Solution. Profit equals 920 minus 800 equals 120 rupees. Profit percent equals 120 hundredths times 100 equals 15%. Question 2. The marked price of the watch is 1,500 rupees. A discount of 20% is given. What is the selling price? Solution. Discount equals 20% of 1,500 equals 300 rupees. Selling price equals 1,500 minus 300 equals 1,200 rupees. Question 3. A shopkeeper marks goods 40% above cost price and allows a 10% discount. What is his gain percentage? Solution. Marked price equals 140 rupees. Assuming CP equals 100 rupees. Selling price equals 90% of 140 equals 126 rupees. Profit equals 126 minus 100 equals 26 rupees. Right pointing arrow. Profit percent equals 26%. Answer. 26%. Let me know your next topic, and I'll continue with the same highly detailed, paragraph-based, SSC-focused lecture format. You said, successive discount, false weights, and dishonest dealers. ChatGPT said, here is your detailed SSC level theory lecture on successive discounts, false weights, and dishonest dealers. As per your request, the lecture is in pure paragraph format, with maximum explanation, no tables or codes, and completely tailored for SSC exams. Successive discounts, full concept. In real-world transactions and SSC exam questions, sellers often offer more than one discount in succession. This means that after applying the first discount to the marked price, a second discount is applied to the reduced price, not the original. This is called a successive discount. The most important formula for successive discounts is net discount percent equals A plus B minus AB 100, where and B are the two successive discount percentages. This formula gives the total or effective discount directly, but it must be remembered that successive discounts do not simply add up. For example, a discount of 10% followed by another 20% is not equal to 30%, but less. Let's understand with an example. Suppose a product has a marked price of 1,000 rupees. A shopkeeper offers two successive discounts, first 10%, then 20%. First discount, 10% of 1,000 rupees equals 100 rupees, so reduced price equals 900 rupees. Second discount, 20% of 900 rupees equals 180 rupees, so final price equals 900 rupees minus 180 rupees equals 720 rupees. Total discount equals 1,000 rupees minus 720 rupees equals 280 rupees, so effective discount percent equals 281 thousandths times 100 equals 28%. This matches the formula. Net discount equals 10 plus 20 minus 10 times 20, 100 equals 30 minus 2 equals 28%. If more than two discounts are applied, say 10%, 15%, and 20%, the formula is extended step by step. First apply the formula to the first two. 10 plus 15 minus 10 times 15 100ths equals 23.5%. Then combine this with 20% using the same formula. 23.5 plus 20 minus 23.5 times 20 100ths equals 43.5 minus 4.7 equals 38.8% total discount. In SSC exams, this type of question is commonly asked in shops and sales contexts, often requiring students to find either the final selling price or the effective discount percentage. It may also be reversed. If effective discount is given and one discount is known, find the second. In that case, work backward using the formula. It is important to note that successive discounts always result in a lower total reduction than simply adding them. This is because each subsequent discount is applied on a reduced amount. This concept also helps explain why big stores advertise multiple discounts, psychologically attractive but mathematically less than simple addition. False weights and dishonest dealers, full concept. This is a classic SSC topic involving deceptive practices by sellers to gain illegal profit by either using false weights or adulteration or by cheating with pricing and measurement. These questions check your logical reasoning with percentage and your ability to apply profit formulas creatively. Let's understand the concept of false weights first. If a dishonest dealer claims to sell 1 kilogram but actually gives less than 1 kilogram, say 950 grams, then he is gaining the difference as extra profit without changing the price. The customer pays for 1 kilogram but receives only 950 grams. The gain percent is calculated as gain percent equals error in weight actual weight given times 100. In our example, error equals 1,000 minus 950 equals 50 grams, and actual weight sold equals 950 grams, so gain percent equals 5950 times 100 approximately equals 5.26%. Let's try another variation. A shopkeeper gives only 800 grams of a product but charges for 1 kilogram. His profit percent is 200 800ths times 100 equals 25%. That means without raising the price or investing more, he is earning 25% profit simply by cheating in weight. Now let us consider dishonest mixing or adulteration, such as mixing cheaper material into costlier ones. Suppose a milk man mixes 1 liter of water, which is free, into 4 liters of milk costing 20 rupees per liter. The cost of 4 liters of milk is 80 rupees. Total quantity equals 5 liters. The cost per liter equals 80 rupees for 5 equals 16 rupees. He is selling at market rate of 20 rupees per liter, so his profit equals 4 rupees per liter, and profit percent equals 4/16 times 100 equals 25%. This type of cheating is also framed as a dishonest dealer mixes cheaper quality stuff or water at no cost into pure goods and sells at the original price. Find his gain percent. In such cases, the formula used is gain percent equals quantity of adulterant total mixture times 100. This is valid when the adulterant is of zero cost and selling price remains the same as cost price of pure goods. There's also another trick used in SSC questions, combining false weights and markup. For example, a shopkeeper marks up his goods by 20% and gives 10% less quantity. Then the total gain is calculated using successive profit logic. Gain 1 equals 20%, gain 2 equals 11.11% because 10% less quantity equals 1 over 0.9. For example, a shopkeeper marks up his goods by 20% and gives 10% less quantity. Then the total gain is calculated using successive profit logic. Gain 1 equals 20%, gain 2 equals 11.11% because 10% less quantity equals 1 over 0.9 minus 1 approximately equals 11.11%. Net gain equals 20 plus 11.11 plus 20 times 11.11, 100 approximately equals 33.33%. These questions require a clear understanding of how gain is achieved without changing price or quality explicitly. Many SSC problems are cleverly worded to test your ability to spot hidden cheating in weight or measure. Practice questions SSC level. Question 1. A shopkeeper offers 2 successive discounts of 10% and 20% on a marked price of 1,000 rupees. What is the final selling price? Solution. First discount equals 100 rupees. New price equals 900 rupees. Second discount equals 20% of 900 equals 180 rupees. Right pointing arrow. Final price equals 720 rupees. Answer. 720 rupees. Question 2. A trader uses false weights and gives only 960 grams instead of 1 kilogram, but charges full price. What is his profit percent? Solution. Profit equals 40 grams. Profit percent equals 4960 times 100 equals 4.17%. Question 3. A milkman mixes 1 liter of water free with 4 liters of milk costing 25 rupees per liter. He sells the mixture at the cost price of milk. What is his gain percent? Solution. Cost equals 100 rupees for 5 liters. Right pointing arrow. Cost per liter equals 20 rupees. Selling price equals 25 rupees. Right pointing arrow. Profit equals 5 rupees per liter. Gain percent equals 5/20 times 100 equals 25%. Let me know your next topic, and I'll prepare the next lecture in the same clear, paragraph-based, SSC-focused style. You said. Use the percentage formula small diamond simple interest and compound interest SI. Formula and problems on annual monthly interest. 2 halves. ChatGPT said. Here is your SSC level theory lecture in pure paragraph format covering. Use the percentage in simple interest SI. Formula of SI and its application in annual and monthly problems. This lecture follows your instruction. No tables, no codes, full paragraph explanation, and maximum clarity for SSC exam preparation. Percentage and its application in simple interest SI. Simple interest is one of the most common real-life applications of percentages, especially in banking, lending, and investment. It is the extra money paid or received for using someone else's money for a fixed time at a fixed rate. The term simple means that the interest is calculated only on the original principal amount, not on accumulated interest. The basic formula for simple interest SI is SI equals P times R times T 100. Here. P stands for the principal amount, initial money lent or borrowed. R stands for the rate of interest per annum per year. Expressed as a percentage. T stands for the time period, usually in years. SI is the simple interest earned or paid. Let us understand the formula through a basic example. Suppose a person lends 10,000 rupees at 5% interest per annum for 2 years. Here, P equals 10,000, R equals 5, T equals 2. So, SI equals 10,000 times 5 times 2, 100 equals rupee 1,000. This means rupee 1,000 is the extra amount earned as interest in 2 years. To find the total amount to be paid or received at the end of the time period, we add the interest to the principal. Total amount equals principal plus simple interest. In the above example, total amount equals 10,000 rupees plus 1,000 rupees equals 11,000 rupees. Monthly interest and conversion of time. In many SSC questions, the interest is calculated not yearly but monthly or for a few months. In such cases, time T must be converted into years. Since a year has 12 months, 6 months is 6/12 equals 0.5 years. For example, if 6,000 rupees is lent at 10% per annum for 6 months, then T equals 6/12 equals 0.5 years. SI equals 6,000 times 10 times 0.5, 100 equals 300 rupees. Another common variation is when rate of interest is given per month instead of per annum. In such cases, convert the rate accordingly. To find the total amount to be paid or received at the end of the time period, we add the interest to the principal. Total amount equals principal plus simple interest. In the above example, total amount equals 10,000 rupees plus 1,000 rupees equals 11,000 rupees. Monthly interest and conversion of time. In many SSC questions, the interest is calculated not yearly but monthly or for a few months. In such cases, time T must be converted into years. Since a year has 12 months, 6 months is 6/12 equals 0.5 years. For example, if 6,000 rupees is lent at 10% per annum for 6 months, then T equals 6/12 equals 0.5 years. SI equals 6,000 times 10 times 0.5, 100 equals 300 rupees. Another common variation is when rate of interest is given per month instead of per annum. In such cases, convert the rate accordingly. For example, if the monthly rate is 1%, then the annual rate is 12%. Or, if the question asks for interest over 4 months at 1% per month, then just apply directly. SI equals P times R times T, 100, where R is 1% per month and T is in months. Let's say 8,000 rupees is borrowed for 4 months at 1% per month. Then R equals 1, T equals 4, P equals 8,000. SI equals 8,000 times 1 times 4, 100 equals 320 rupees. This technique is especially useful when solving questions involving short-term borrowings or installments. Reverse calculations and missing term problems. In SSC exams, you may also be asked to find any missing term, principal, rate, time, or interest using rearranged versions of the SI formula. To find principal P equals SI times 100 R times T. To find rate R equals SI times 100 P times T. To find time. To find principal P equals SI times 100 R times T. To find rate R equals SI times 100 P times T. To find time T equals SI times 100 P times R. For example, if SI equals 600 rupees, R equals 5%, T equals 3 years, then P equals 600 times 100, 5 times 3 equals 4,000 rupees. You may also be given the total amount instead of SI. In that case, subtract the principal from the amount to get SI, then proceed. Example, a person receives 5,250 rupees after 2 years at 5% interest. Find the principal. Let amount equals 5,250 rupees. Assume principal equals P, so interest equals 5,250 rupees minus P. Now use SI formula. P times 5 times 2, 100 equals 5,250 minus P. Solve the equation to get P equals 5,000 rupees. Such questions test your ability to apply algebra and rearrange formulas, and are frequently seen in Tier 1 and Tier 2 SSC exams. Practice questions SSC level. Question 1. Find the simple interest on 12,000 rupees for 3 years at 8% per annum. Solution. SI equals 12,000 times 8 times 3, 100 equals 2,880 rupees. Answer. 2,880 rupees. Question 2. What will be the interest on 5,000 rupees for 6 months at 10% per annum? Solution. Time equals 6 12 equals 0.5 years. SI equals 5,000 times 10 times 0.5. 100 equals 250 rupees. Answer. 250 rupees. Question 3. A sum becomes 6,600 rupees in 3 years at 10% per annum simple interest. Find the principal. Solution. Let principal equals P. SI equals 6,600 minus P. So, P times 10 times 3. 100 equals 6,600 minus P. Solving. 0.3 P equals 6,600 minus P right pointing arrow 1.3 P equals 6,600 right pointing arrow P equals 6,600 over 1.3 equals 5,076 rupees and 92 paise approximately. Let me know when you're ready for the next topic. Compound interest or anything else. I'll continue in the same exam focused, paragraph-based format. Tools. Choose files, no file chosen, choose files, no file chosen. ChatGPT can make mistakes. Check. Basic and compound interest formula. Annual compounded periodically. Difference between SI and C. ChatGPT said. Here's a complete theory lecture on simple interest SI and compound interest C formulas, including annual and periodic compounding, and a detailed explanation of the differences between SI and C, based on SSC level quantitative aptitude syllabus, with clear step-by-step conceptual clarity and shortcut awareness where applicable. Small diamond simple interest SI, small diamond concept. Simple interest is the extra amount paid or earned only on basic and compound interest formula. Annual compounded periodic. SSC level quantitative aptitude. ChatGPT said. Here's a complete theory lecture on simple interest SI and compound interest C formulas, including annual and periodic compounding, and a detailed explanation of the differences between SI and C, based on SSC level quantitative aptitude syllabus, with clear step-by-step conceptual clarity and shortcut awareness where applicable. Small diamond simple interest SI, small diamond concept. Simple interest is the extra amount paid or earned only on the principal amount over a period of time. Interest does not compound or accumulate. Small diamond formula. SI equals P times R times T, 100. Where P equals principal, initial amount. R equals annual rate of interest percent. T equals time in years. SI is always calculated on the original principal throughout the time period. Small diamond total amount A equals P plus SI. Small diamond compound interest C, small diamond concept. Compound interest is the interest calculated on the initial principal and also on the accumulated interest from previous periods. This is interest on interest. Small diamond when compounded annually. The formula is A equals P times 1 plus R 100 to the power of N. Where A equals total amount after N years. P equals principal. R equals rate of interest percent. N equals time in years. Then C equals A. P equals P times 1 plus R 100 to the power of NP. Small diamond when compounded half yearly. Rate becomes R2. Time becomes 2N equals P times 1 plus R 200 squared to the power of N. Small diamond when compounded quarterly. Rate becomes R4. Time becomes 4N equals P times 1 plus R 400 to the power of 4 to the power of N. Small diamond key differences between SI and C aspect simple interest SI compound interest CI. Interest base is calculated only on the original principal calculated on principal plus accumulated interest growth type linear growth exponential growth. Formula SI equals P times R times T 100 C equals P times 1 plus R 100 to the power of N 1 amount A equals P plus SI equals P times 1 plus R 100 to the power of N returns less than C over time more than SI due to compounding effect usage often used in loans, short-term borrowings common in savings accounts, investments, FDs, etc. Small diamond shortcut. Difference between C and SI for 2 years when time equals 2 years. You can use this formula to quickly find the difference. C SI equals P times R squared 100 squared. This shortcut helps in MCQs where you're directly asked the difference between C and SI for 2 years. Small diamond example. Small diamond example. Small diamond example 1. SI basic. Find the simple interest on 5,000 rupees at 10% per annum for 3 years. SI equals 5,000 times 10 times 3. 100 equals 1,500 rupees. A equals 5,000 plus 1,500 equals 6,500 rupees. Small diamond example 2. C annual. Find compound interest on 5,000 rupees at 10% P. A for 3 years. A equals 5,000 times 1 plus 10 100 cube equals 5,000 times 1.1 cube equals 5,000 times 1.331 equals 6,655 rupees. C equals 6,655. 5,000 equals 1,655 rupees. Small diamond example 3. Difference between SI and C for 2 years. P equals 1,000 rupees. R equals 10%. T equals 2 years. Difference equals 1,000 times 10 squared. 100 squared equals 1,000 times 110,000 equals 10 rupees. Small diamond MCQs for practice. Find the simple interest on 6,000 rupees at 5% P. A for 4 years. A 1,000 rupees. B 1,200 rupees. C 1,500 rupees. D 1,800 rupees. Checkmark answer. B. SI equals 6,000 times 5 times 4. 100 equals 1,200 rupees. Find the compound interest on 2,000 rupees at 10% P. A for 2 years. A 400 rupees. B 420 rupees. C 440 rupees. D 500 rupees. Checkmark answer. B. A equals 2,000 times 1.1 squared equals 2,000 times 1.21 equals 2,420 rupees. C equals 2420. 2,000 equals 420 rupees. Find the difference between C and SI on 8,000 rupees at 12% for 2 years. A 100 rupees. B 120 rupees. C 115 rupees and 20 paise. D 122 rupees and 40 paise. Checkmark answer. D. Difference equals 8,000 times 12 squared. 100 squared equals 8,000 times 144 10,000 equals 115 rupees and 20 paise. C equals 8,000 times 1.12 squared equals 8,000 times 1.2544 equals 10,035 rupees and 20 paise. C equals 10,035 rupees and 20 paise. 8,000 equals 2,035 rupees and 20 paise. SI equals 8,000 times 12 times 2. 100 equals 1,920 rupees. Difference equals 2,035 rupees and 20 paise minus 1,920 rupees equals 115 rupees and 20 paise. Checkmark correct answer. C. Let me know if you want practice questions with trick methods or compound interest cases like compounded half yearly, monthly, quarterly. You said. Installment-based C problems using growth formulae. ChatGPT said. Here's a complete theory lecture on compound interest C problems involving installments and growth formulae, designed for SSC level quantitative aptitude, with maximum clarity, conceptual understanding, shortcuts, and solved examples. Small diamond installment-based compound interest problem. Small diamond concept. In installment-based C problems, a borrower repays a loan in equal annual or periodic installments, which include both principal and interest. The total of these installments is calculated using the compound interest formula in reverse. Small diamond case 1. Repaying a loan in equal annual installments let P equals principal loan amount. R equals rate of compound interest per annum. N equals number of equal installments. A equals amount of each installment. The total of all installments with C equals loan principal. Small diamond formula. If the borrower pays equal annual installments at the end of each year, then the formula is P equals A 1 plus R 100 N minus 1 1 plus R 100 N dot operator R 100. P equals A 1 plus R 100 N. Dot operator R 100 1 plus R 100 N. Minus 1. This is derived from the present value of an annuity in C context. Small diamond steps to solve. Identify P, R, N. Substitute in the formula and calculate A. Alternatively, you may be given and asked to find P. Small diamond example 1. A person took a loan of 15,000 rupees at 10% compound interest per annum. He agrees to repay it in 2 equal yearly installments. Find the value of each installment. Solution. Here. P equals 15,000. R equals 10%. N equals 2. Using P equals A 1 plus R 100 N minus 1 1 plus R 100 N dot operator R 100. P equals A 1 plus R 100 N. Dot operator R 100 1 plus R 100 N. Minus 1 15,000 equals. Up 1.12 minus 1 1.12 dot operator. 0.10. 15,000 equals A 1.12. Dot operator 0.10 1.12. Minus 1 15,000 equals. A 1.21 minus 1 1.21 dot operator. 0.10 equals A 0.21 0.121. Approximately equals 8 times 1.7. A equals P 1 plus. Small diamond growth formula. Small diamond growth formula. If a quantity increases by R% per period, then after n periods, the final value is A equals P 1 plus R 100 N. A equals P 1 plus R 100 N. Small diamond depreciation formula. If a quantity decreases by R% per period, then A equals P 1 minus R 100 N. A equals P 1 minus R 100 N. These formulas are used in population growth, price inflation, machine depreciation, investment doubling, tree growth, etc. Small diamond example 2. Population growth. The population of a town increases by 5% annually. If its present population is 20,000, what will it be after 3 years? Solution. Using growth formula. A equals 20,000 times 1 plus 5 100ths 3 equals 20,000 times 1.157625 equals rupee. 23,152.508 equals 20,000 times 1 plus 5 100ths 3 equals 20,000 times 1.15765 equals 23,152 rupees and 50 paise check mark. Population after 3 years equals 23,152. Small diamond example 3. Machine depreciation. A machine costs 50,000 rupees. It depreciates at 10% per annum. What will be its value after 2 years? Solution. A equals 50,000 times 1 minus 10 100ths 2 equals 50,000 times 0.92 equals 50,000 times 0.81 equals 40,500 rupees. A equals 50,000 times 1 minus 10 100ths 2 equals 50,000 times 0.92 equals 50,000 times 0.81 equals 40,500 rupees. Check mark. Value after 2 years equals 40,500 rupees. Small diamond shortcut for growth. Depreciation over 2 years. Use the identity. 1 plus or minus R 100 2 equals 1 plus or minus 2 R 100 plus R 2. 10,000 1 plus or minus R 102 equals 1 plus or minus 2 R 100 plus R 2. 10,000. For quick estimation. Small diamond practice MCQs. A person repays a loan of 9,000 rupees in 2 equal yearly installments at 10% C. Find each installment. A 4,900 rupees. B 5,200 rupees. C 5,227 rupees and 27 paise. D 5,250 rupees. Check mark. Answer. C using formula. 9,000 equals 8 times 1.1 square 1 1.1 square times 0.10. 9,000 equals 8 times 1.722. Approximately equals 5,227 rupees and 27 paise. A vehicle worth 120,000 rupees depreciates at 10% per annum. What will be its value after 2 years? A 96,000 rupees. B 97,200 rupees. C 98,000 rupees. D 99,000 rupees. Check mark. Answer. B. Value equals 120,000 times 0.9 squared equals 120,000 times 0.81 equals 97,200 rupees. If the population of a village grows at 8% annually and is 27,000 now, what was it 2 years ago? A 23,500 rupees. B 23,140 rupees. C 23,140 rupees and 49 paise. D 24,000 rupees. Check mark. Answer. C. Let original population equals PP times 1.08 squared equals 27,000. P equals 27,000 over 1.1664 approximately equals 23,140 rupees and 49 paise. If you'd like, I can provide installment-based C problems using half-yearly or quarterly installments, or more practice sets on growth decay using compound interest. Let me know. You said. No tables from now on, please. No code 2. Don't say anything. ChatGPT said. Compound interest. C. Installment-based problems and growth-based problems are advanced applications of the compound interest formula where interest is compounded periodically and repayments or growth occur in stages or steps. In installment-based C problems, the borrower repays the principal and interest in equal amounts over a fixed number of years. This involves calculating the present value of annuities under compound interest conditions. If a person borrows a sum and repays it in equal annual installments over a certain period at a fixed rate of compound interest, each installment includes interest on the outstanding principal and part of the principal itself. The formula to calculate the equal annual installment is derived from the present value of a compound interest annuity. Principal equals the installment multiplied by the ratio of the compound interest factor. If the annual installment is A, principal is P, rate is R%, and period is n years, then the formula uses P equals 8 times 1 plus R 100 to the power of n 1 plus R 100 to the power of n times R 100. This expression gives the present value of all the future installments. It is often used to calculate the fixed amount to be paid yearly to repay a loan taken with compound interest. In problems where the installment amount is given and the principal is to be calculated, we substitute the known values and solve accordingly. In reverse, if the principal and interest rate are given, the installment can be computed using this formula. Growth-based compound interest problems involve quantities increasing or decreasing over time, like population growth, inflation, value of money, tree height, etc. If a quantity grows by R% annually, the formula is equals P 1 plus R 100 to the power of n, where P is the initial value, A is the amount after n years, and R is the growth rate. In the case of depreciation or reduction, the formula becomes equals P 1 R 100 to the power of n. These are direct applications of the compound interest principle, where the growth or reduction is compounding every year. The difference between such growth-based C and normal C problems is that instead of money, other physical or demographic quantities are involved, but the logic remains the same. These formulas are extensively used in questions related to population projection, machine value depreciation, increase in cost of goods, or any regularly compounding process. Shortcut identities like 1 plus R 100 squared approximately equals 1 plus 2 R 100 plus R squared 10,000 help in estimation for 2-year growth problems. For example, if a man borrows 18,000 rupees at 10% compound interest and wants to repay it in 2 equal annual installments, we use the installment formula and find the amount he must pay annually. Another example is a population of a town being 40,000 and increasing at 5% per annum. To find the population after 3 years, we apply the formula directly and calculate it equals 40,000 times 1.05 cubed. Similarly, in depreciation, if the value of a machine worth 60,000 rupees depreciates at 10% per annum, its value after 2 years is found using equals 60,000 times 0.9 squared. The amount decreases each year due to compounded loss in value. These types of compound interest applications frequently appear in SSC and other competitive exams due to their real-life relevance and mathematical depth. Regular practice and familiarity with formulas, especially installment-based and growth decay formulas, is key to mastering this topic. You said, time and work. Work efficiency, I can do a work in X days. Pipes and cisterns. ChatGPT said, time and work is a fundamental topic in quantitative aptitude, particularly relevant to exams like SSC. It deals with problems involving how fast individuals or machines can complete a task, and how the work combines or differs over time. This topic also includes the concept of pipes and cisterns, which is a variation of the same idea involving filling or emptying tanks. Time and work problems rely on the concept of work equivalence. If a person can do a job in X days, their work rate is considered 1x of the work per day. This means the faster the worker, the greater their daily work rate. For example, if it can complete a task in 10 days, A's efficiency is 1/10 of the work per day. Similarly, if B can complete the same task in 15 days, B's efficiency is 1/15. When A and B work together, their combined work rate is the sum of their individual work rates, i.e., 1/10 plus 1/15. This concept can be extended to 3 or more workers. A commonly used technique is the LCM method. Instead of working with fractions, assume the total work is the least common multiple of the days taken by the workers. This simplifies calculations, particularly when comparing efficiencies or computing remaining work. For instance, if it can do a job in 6 days and B in 4 days, assume total work is 12 units. A does 2 units per day, and B does 3 units per day. Working together, they do 5 units per day, completing the work in 12 fifths equals 2.4 days. Work efficiency comparisons also appear in problems where one worker is more or less efficient than another. For example, if A is 50% more efficient than B, A's work rate is 1.5 times that of B. Alternatively, if it is a piece of work in 20 days and B is twice as efficient, B will complete it in 10 days. These relationships are important in questions involving ratios and comparative work rates. Pipes and cisterns problems are based on the same principles as time and work. A pipe filling a tank is like a person doing work, while a pipe draining the tank is like a person undoing work. If a pipe can fill a tank in X hours, it fills 1x of the tank per hour. If another pipe empties it in Y hours, it empties 1y per hour. When both are open, the net rate is 1x1y if the drain is strong. Pipes and cisterns problems are based on the same principles as time and work. A pipe filling a tank is like a person doing work, while a pipe draining the tank is like a person undoing work. If a pipe can fill a tank in X hours, it fills 1x of the tank per hour. If another pipe empties it in Y hours, it empties 1y per hour. When both are open, the net rate is 1x1y if the drain is stronger, or 1x plus 1y if both fill. If a tank is filled in 6 hours by pipe A and emptied in 8 hours by pipe B, the net work per hour is 1/618 equals 1/24. The tank will be full in 24 hours. Some problems involve alternate filling and emptying. If a pipe fills for X minutes and another empties for Y minutes repeatedly, compute work done in each cycle and extrapolate to the total. Advanced problems also include partial work scenarios, such as one person leaving midway or joining later. These require dividing the work into segments based on time and applying the concept of rate times time equals work for each segment. Shortcuts and identities are useful. If A and B together can complete a work in X days and alone in Y days, then B's time equals X, Y, Y, X. If 3 people work together and the time taken in pairs is given, the total can be calculated by setting equations using the given data. Pipes and cisterns problems may also involve inlet and outlet combinations and time-based actions such as opening or closing valves after certain durations. A classic example, I can do a job in 12 days, B in 18 days. Working together, they complete it in 1/12 plus 1/18 equals 5/36 per day, so total time is 36 fifths equals 7.2 days. Another example, a pipe fills a tank in 5 hours, another empties it in 8 hours. Together, they fill at a rate of 1/5 1/8 equals 3/40 of per hour. Time to fill is 40 thirds equals 13.33 hours. These problems are practical and can be mastered with consistent practice and a strong grasp of fundamental principles. You said. LCM method to solve work-based problems. Mandate concept. Alternate days work. ChatGPT said. The LCM method, mandate concept, and alternate days work are 3 powerful strategies for solving time and work problems efficiently, especially in competitive exams like SSC. These methods simplify complex calculations and make it easier to deal with multiple workers, changing work rates, or alternating work schedules. The LCM method involves assuming the total work is the least common multiple of the number of days taken by each worker. This helps in avoiding fractional calculations and makes it easier to find daily efficiencies. Suppose it can do a work in 12 days and B in 18 days. Instead of taking total work as 1 unit, assume total work equals LCM of 12 and 18 equals 36 units. A's daily work equals 36 divided by 12 equals 3 units per day. B's daily work equals 36 divided by 18 equals 2 units per day. Together, A and B complete 3 plus 2 equals 5 units per day. Hence, the work will be completed in 36 divided by 5 equals 7.2 days. The LCM method also helps when multiple workers start and leave the work at different times. It turns abstract percentages and ratios into concrete numerical values that are easier to manipulate. The mandate concept is based on the idea that total work equals number of men times number of days times hours per day. It helps solve problems where the number of workers or working hours changes. If 5 men can complete a task in 10 days, then total work equals 5 times 10 equals 50 man days. This means 50 men working for 1 day can also complete the task, or 10 men in 5 days. It is useful in determining how long a task will take if the workforce increases or decreases. If a work requires 120 man days and 8 men are available, then time equals 120 divided by 8 equals 15 days. This method is especially powerful in project-based questions where different teams work for different durations. Alternate days work involves scenarios where 2 workers work on alternate days. For example, A and B work on alternate days starting with suppose A can do the work in 6 days and B in 12 days. Using the LCM method, total work equals LCM of 6 and 12 equals 12 units. A's rate equals 2 units per day, B's equals 1 unit per day. In 2 days, A and B together complete 3 units. So in every 2-day cycle, 3 units are completed. To find how many such 2-day cycles fit into 12 units, divide 12 by 3 equals 4 cycles equals 8 days. Hence, the work will be completed in 8 days. If the total work is not a multiple of the 2-day cycle work, handle the last day separately based on who works that day. Another example, A and B work on alternate days starting with B A finishes the work in 4 days, B in 6 days. Total work equals 12 units. A's rate equals 3 units per day, B's equals 2 units per day. In each 2-day cycle, B then A 2 plus 3 equals 5 units are done. 2 such cycles equals 10 units in 4 days. 2 units remain, and B works on day 5, doing 2 units. So, work finishes in 5 days. In complex problems, combining these concepts helps. If men and women work together alternate, or if part of the work is done by one and the rest by another, use the LCM method to define total work. Apply the mandate principle to convert between workers and time, and use alternate day logic to assign specific amounts of work per cycle. These tools give a structured, logical method to solve problems quickly and correctly. You said. Work sharing problems small time and time, speed and distance relative speed, same direction and opposite direction. ChatGPT said. Work sharing problems in time, speed, and distance including relative speed are classic topics in quantitative aptitude. Both require a clear understanding of ratios, unit work, and the relationships between time, rate, and output or movement. Below is a complete conceptual explanation of these interconnected areas with direct focus on exam level application. Work sharing problems involve distributing wages or profits among multiple workers based on the amount of work each has done. The key principle is share proportional work done proportional efficiency times time worked. If A and B complete a work together and earn a total wage W, and A's efficiency is double that of B, then it will earn twice as much as B when time is different. Work done by each person is calculated using efficiency times number of days worked. For example, if A and B together earn 900 rupees for work, and it works for 6 days and B for 4 days, with A doing 2 units per day and B 3 units per day, A's work equals 12 units and B's work equals 12 units. So they share equally, 450 rupees each. If a third person C joins midway, total work done by each is calculated separately before distributing earnings. When time taken is given instead of efficiency, efficiency is taken as inverse. If A finishes in 6 days and B in 12, their efficiencies are 1/6 and 1/12 respectively. Multiply by days work to find total contribution. For complex cases, assume total work using LCM method, calculate units of work done by each, and divide money in the ratio of work done. Time, speed and distance problems are based on the formula distance equals speed times time. If any two variables are given, the third can be found. If a vehicle travels 60 kilometers in 2 hours, speed equals 60 divided by 2 equals 30 km per hour. If speed is 40 kilometers per hour and time is 3 hours, distance equals 40 times 3 equals 120 kilometers. Units must be consistent. Convert minutes to hours or meters to kilometers when needed. Problems often involve average speed, where total distance and total time must be used. For example, if a car covers 60 kilometers at 30 kilometers per hour and returns at 60 kilometers per hour, the average speed is not 45 but 2 a plus b equals 2 times 30 times 60. 30 plus 60 equals 40 kilometers per hour. Relative speed is used when two objects move simultaneously, either towards each other or in the same direction. If two bodies move in the same direction, relative speed equals difference of speeds. If they move in opposite direction, relative speed equals sum of speeds. This concept is often used in problems involving trains, boats, or people walking on moving platforms. Example, a train moving at 60 kilometers per hour overtakes a person walking at 6 kilometers per hour in the same direction. Relative speed equals 60 to 6 equals 54 kilometers per hour equals 15 meters per second. If the train is 300 meters long, time to pass equals 300 divided by 15 equals 20 seconds. If another train approaches from the opposite direction at 90 kilometers per hour, relative speed equals 60 plus 90 equals 150 kilometers per hour equals 41.67 meters per second. If the train is 250 meters long, time to cross equals 250 divided by 41.67 approximately equals 6 seconds. For boats and streams, speed in still water is combined with stream speed. Downstream speed equals boat plus stream, upstream equals boat, stream. If downstream speed is 12 kilometers per hour and upstream is 8 kilometers per hour, boat speed equals 12 plus 8, 2 equals 10 kilometers per hour. Stream speed equals 12 to 8, 2 equals 2 kilometers per hour. These problems also use the same core identity of distance equals speed times time. Linking these topics, when a man walks on a moving platform, or two people work and move alternately, both work sharing and relative speed ideas are tested. A good grasp of basic ratios and careful attention to direction and units is essential to solve such problems accurately. The LCM method, man-day concept, and alternate days work are three powerful strategies for solving time and work problems efficiently, especially in competitive exams like SSC. These methods simplify complex calculations and make it easier to deal with multiple workers, changing work rates, or alternating work schedules. The LCM method involves assuming the total work is the least common multiple of the number of days taken by each worker. This helps in avoiding fractional calculations and makes it easier to find daily efficiencies. Suppose I can do a work in 12 days and B in 18 days. Instead of taking total work as 1 unit, assume total work equals LCM of 12 and 18 equals 36 units. A's daily work equals 36 divided by 12 equals 3 units per day. B's daily work equals 36 divided by 18 equals 2 units per day. Together, A and B complete 3 plus 2 equals 5 units per day. Hence, the work will be completed in 36 divided by 5 equals 7.2 days. The LCM method also helps when multiple workers start and leave the work at different times. It turns abstract percentages and ratios into concrete numerical values that are easier to manipulate. The man-day concept is based on the idea that total work equals number of men times number of days times hours per day. It helps solve problems where the number of workers or working hours changes. If 5 men can complete a task in 10 days, then total work equals 5 times 10 equals 50 man days. This means 50 men working for 1 day can also complete the task, or 10 men in 5 days. It is useful in determining how long a task will take if the workforce increases or decreases. If a work requires 120 man days and 8 men are available, then time equals 120 divided by 8 equals 15 days. This method is especially powerful in project-based questions where different teams work for different durations. Alternate days work involves scenarios where two workers work on alternate days. For example, A and B work on alternate days starting with suppose A can do the work in 6 days and B in 12 days. Using the LCM method, total work equals LCM of 6 and 12 equals 12 units. A's rate equals 2 units per day, B's equals 1 unit per day. In 2 days, A and B together complete 3 units. So in every 2-day cycle, 3 units are completed. To find how many such 2-day cycles fit into 12 units, divide 12 by 3 equals 4 cycles equals 8 days. Hence, the work will be completed in 8 days. If the total work is not a multiple of the 2-day cycle work, handle the last day separately based on who works that day. Another example, A and B work on alternate days starting with B finishes the work in 4 days, B in 6 days. Total work equals 12 units. A's rate equals 3 units per day, B's equals 2 units per day. In each 2-day cycle, B then A 2 plus 3 equals 5 units are done. 2 such cycles equals 10 units in 4 days. 2 units remain, and B works on day 5, doing 2 units. So, work finishes in 5 days. In complex problems, combining these concepts helps. If men and women work together or alternate, or if part of the work is done by one and the rest by another, use the LCM method to define total work. Apply the man-day principle to convert between workers and time, and use alternate day logic to assign specific amounts of work per cycle. These tools give a structured, logical method to solve problems quickly and correctly. You said. Work sharing problem, small time and time, speed and distance, relative speed, same direction and opposite direction. ChatGPT said. Work sharing problems in time, speed, and distance, including relative speed, are classic topics in quantitative aptitude. Both require a clear understanding of ratios, unit work, and the relationships between time, rate, and output or movement. Below is a complete conceptual explanation of these interconnected areas with direct focus on exam level application. Work sharing problems involve distributing wages or profits among multiple workers based on the amount of work each has done. The key principle is share proportional work done proportional efficiency times time worked. If A and B complete a work together and earn a total wage W, and A's efficiency is double that of B, then it will earn twice as much as B when time is different. Work done by each person is calculated using efficiency times number of days worked. For example, if A and B together earn 900 rupees for work, and works for 6 days and B for 4 days, with A doing 2 units per day and B 3 units per day, A's work equals 12 units and B's work equals 12 units. So they share equally, 450 rupees each. If a third person C joins midway, total work done by each is calculated separately before distributing earnings. When time taken is given instead of efficiency, efficiency is taken as inverse. If A finishes in 6 days and B in 12, their efficiencies are 1/6 and 1/12 respectively. Multiply by days work to find total contribution. For complex cases, assume total work using LCM method, calculate units of work done by each, and divide money in the ratio of work done. Time, speed and distance problems are based on the formula distance equals speed times time. If any two variables are given, the third can be found. If a vehicle travels 60 kilometers in 2 hours, speed equals 60 divided by 2 equals 30 kilometers per hour. If speed is 40 kilometers per hour and time is 3 hours, distance equals 40 times 3 equals 120 kilometers. Units must be consistent. Convert minutes to hours or meters to kilometers when needed. Problems often involve average speed, where total distance and total time must be used. For example, if a car covers 60 kilometers at 30 kilometers per hour and returns at 60 kilometers per hour, the average speed is not 45 but 2 a plus b equals 2 times 30 times 60. 30 plus 60 equals 40 kilometers per hour. Relative speed is used when two objects move simultaneously, either towards each other or in the same direction. If two bodies move in the same direction, relative speed equals difference of speeds. If they move in opposite direction, relative speed equals sum of speeds. This concept is often used in problems involving trains, boats, or people walking on moving platforms. Example, a train moving at 60 kilometers per hour overtakes a person walking at 6 kilometers per hour in the same direction. Relative speed equals 60 to 6 equals 54 kilometers per hour equals 15 meters per second. If the train is 300 meters long, time to pass equals 300 divided by 15 equals 20 seconds. If another train approaches from the opposite direction at 90 kilometers per hour, relative speed equals 60 plus 90 equals 150 kilometers per hour equals 41.67 meters per second. If the train is 250 meters long, time to cross equals 250 divided by 41.67 approximately equals 6 seconds. For boats and streams, speed in still water is combined with stream speed. Downstream speed equals boat plus stream, upstream equals boat, stream. If downstream speed is 12 kilometers per hour and upstream is 8 kilometers per hour, boat speed equals 12 plus 8, 2 equals 10 kilometers per hour. Stream speed equals 12 to 8, 2 equals 2 kilometers per hour. These problems also use the same core identity of distance equals speed times time. Linking these topics, when a man walks on a moving platform, or two people work and move alternately, both work sharing and relative speed ideas are tested. A good grasp of basic ratios and careful attention to direction and units is essential to solve such problems accurately. You said, trains. Boats and streams average speed. ChatGPT said. Trains, boats and streams, and average speed are essential subtopics under time, speed, and distance in SSC level quantitative aptitude. These involve variations of the core formula, distance equals speed times time, adapted to specific real-life motion scenarios like moving platforms, currents, or return journeys. Trains problems typically involve the train's length, its speed, and the object it crosses, either a stationary object like a pole or a moving one like a person, another train, or a platform. The length of the train is equivalent to the distance it covers when passing a stationary object. If a train of length L meters moves at s meter per second and crosses a pole in t seconds, then L equals s times t if the same train crosses a platform of length p in t seconds, then total distance is L plus p equals s times t when two trains cross each other, either in the same or opposite direction. Relative speed is used. In opposite direction, relative speed is the sum of their speeds. In same direction, it is the difference. For example, if a train of 120 meters at 20 meters per second crosses another train of 80 meters at 10 meters per second in the same direction, time taken equals 120 plus 80 divided by 20 to 10 equals 200 divided by 10 equals 20 seconds. In cases involving trains crossing moving persons, relative speed is used. If a person walks at 3 kilometers per hour and the train moves at 60 kilometers per hour in the same direction, relative speed equals 60 to 3 equals 57 kilometers per hour equals 15.83 meters per second. A 200 meters train will pass in 200 divided by 15.83 approximately equals 12.63 seconds. For train problems, always convert kilometer per hour to meter per second by multiplying with 5/18ths, and meter per second to kilometer per hour by multiplying with 18/5. Boats and streams problems revolve around the effect of water current on the speed of a boat. The boat has a speed in still water, while the stream can assist or resist its motion. Downstream speed equals boat speed plus stream speed. Upstream speed equals boat speed, stream speed. For example, if a boat moves at 10 kilometers per hour in still water and the stream flows at 2 kilometers per hour, downstream speed equals 12 kilometers per hour, upstream equals 8 kilometers per hour. If it takes 1 hour to go downstream and 1.5 hours upstream over the same distance, that distance is common and can be found using d equals speed times time. Downstream distance equals 12 times 1 equals 12 kilometers, upstream equals 8 times 1.5 equals 12 kilometers, confirming that both trips cover the same distance. To find boat speed and stream speed given upstream and downstream speeds, use boat speed equals t plus u2, stream speed equals t, u2. Boats and streams questions often include time-based comparisons. If the time to cover a certain distance downstream is 2 hours and upstream is 3 hours, average speed equals total distance divided by total time equals 2 divided by 2 plus 3 equals 2 divided by 5. Always use the same units, and apply logic carefully in word-based scenarios. Average speed problems are crucial when speed varies over different parts of a journey. The general formula for average speed is average speed equals total distance divided by total time. A common trap is assuming the average of two speeds is the arithmetic mean. This is incorrect when the distances are equal but speeds differ. In such cases, use average speed equals 2 ab a plus b, where and b are speeds for equal distances. For example, if a car travels to a place at 40 kilometers per hour and returns at 60 kilometers per hour, average speed equals 2 times 40 times 60 divided by 40 plus 60 equals 48 kilometers per hour. For example, if a car travels to a place at 40 kilometers per hour and returns at 60 kilometers per hour, average speed equals 2 times 40 times 60 divided by 40 plus 60 equals 48 kilometers per hour. If time taken is equal and distances differ, you cannot use this shortcut. Instead, use total distance and total time. In mixed situations involving rest periods or different speeds for different legs of a journey, break down each segment and compute the individual times and distances. Add them to find total time and total distance, then apply the basic formula. Example, a person travels 30 kilometers at 60 kilometers per hour and 60 kilometers at 30 kilometers per hour. Time equals 30 divided by 60 plus 60 divided by 30 equals 0.5 plus 2 equals 2.5 hours. Total distance equals 90 kilometers. Average speed equals 90 divided by 2.5 equals 36 kilometers per hour. These topics are frequently tested in SSC exams because they assess practical understanding of motion, conversion, and ratio handling. With clear concepts and unit consistency, such problems can be solved quickly and accurately. You said. Unit conversion meter per second left right arrow kilometer per hour problems on late arrival or early reaching. ChatGPT said. Unit conversion between meters per second, and kilometers per hour is fundamental in all time, speed, and distance problems. It ensures consistency in calculations and helps avoid incorrect answers due to mismatched units. The second part, late arrival or early reaching problems, tests logical application of time-speed distance relationships in real-life scenarios like catching a train or reaching school. To convert meter per second to kilometer per hour, multiply the value by 18/5. This is because 1 meter per second equals 1 times 60 times 60. Meters per hour equals 3,600 meters per hour equals 3.6 kilometers per hour. So, meter per second times 18/5 equals kilometer per hour. For example, 10 meters per second equals 10 times 18/5 equals 36 kilometer per hour. To convert kilometer per hour to meter per second, multiply by 5/18. For example, 72 kilometers per hour equals 72 times 5/18 equals 20 meters per second. When solving problems, if distance is in meters and time in seconds, speed must be in meter per second. If distance is in kilometers and time in hours, speed must be in kilometer per hour. Always make sure that all units match before applying the formula. Speed equals distance divided by time. Now moving to late arrival or early reaching problems. These problems are based on the fact that if a person changes their speed, they may reach earlier or later than the scheduled time. The key idea is that the time difference remains constant and the distance is the same, but the speed changes. For example, if a person normally walks at 4 kilometers per hour and is 10 minutes late, but if he walks at 6 kilometers per hour he reaches 5 minutes early, the total time difference is 15 minutes. Convert that to hours. 15/60 equals 1/4 hours. To solve such problems, use the identity distance slower speed, distance faster speed equals time difference in hours. For example, let the distance be d km. Then d4 d 6 equals 1/4 right pointing arrow take LCM of 4 and 6 equals 12. 3 d2 d 12 equals 1/4 right pointing arrow d equals 3 kilometers. Alternatively, the shortcut formula is distance equals product of speeds times time difference. Difference of speeds. Use this only when the person is late at one speed and early at another. In the above case, distance equals 4 times 6 times 1/4. 6 to 4 equals 24. 8 equals 3 kilometers. Another type is when someone leaves earlier or later than usual and reaches at a different time. Here, speed is constant, but time and departure vary. If someone is late by 5 minutes when leaving at 8 a.m., but early by 10 minutes when leaving at 7:45 a.m., the difference in departure time is 15 minutes, and the change in arrival is also 15 minutes. The total effect equals 30 minutes equals 1/2 hour. Let the speed be s and distance be then. D equals s times t, and by comparing the two scenarios, we deduce either the speed or the distance. These problems require close reading and careful conversion of units. Always express minutes as fractions of an hour, and ensure consistency in speed units. Keep in mind whether the speed increases or decreases, and whether the person is early or late. The logic rests on constant distance and change time or constant time and change speed. Practice with varied examples helps build intuition and speed in solving such problems. You said, averages. Basic average concept weighted average. ChatGPT said. Averages form a fundamental part of quantitative aptitude and appear frequently in SSC level exams. The concept of averages helps in finding a central or typical value from a group of numbers. The two key components are the basic average and the weighted average, both of which are applications of the same core principle but in different contexts. The basic average is defined as the sum of quantities divided by the number of quantities. The formula is average equals sum of all quantities divided by number of quantities. For example, if the ages of 5 people are 20, 25, 30, 35, and 40, the average age equals 20 plus 25 plus 30 plus 35 plus 40 divided by 5 equals 150 divided by 5 equals 30. The average can also be affected when new items are added or removed. If the average of 5 numbers is 40, total sum equals 5 times 40 equals 200. If a sixth number 50 is added, new sum equals 250, new average equals 250 divided by 6 approximately equals 41.66. This reverse multiplication approach, average times number equals total, is useful for finding unknowns when average and count are known. When the average of a group increases or decreases upon replacing or adding